Okay, so let's talk about these four examples about parallel, perpendicular, and neither. So if you watch this video or you paid really close attention to the notes, you'll know that we talked a lot about how to find slopes, how to calculate slopes. And the second part was about what the slopes have to look like, what do the rules have to be to tell the parallel or perpendicular. And so just to recall before we jump in here, once we calculated the slopes, if the slopes are the same, that means we're going to call them parallel. If they're opposite reciprocals, meaning that the fractions have flipped and the sign has changed from positive to negative or negative to positive, we call them perpendicular. And if it's neither one of those categories, we say they're just intersecting, which gives us a roadmap on how we're going to solve these problems. So what we're going to do on each one of these is first get the slopes and then compare the slopes to see which of those rules it follows. Now for this first example, both of these lines are given to us in y equals mx plus b form, slope-intercept form, so y equals mx plus b. And so if we recall from our notes or from memory, that's going to be our slope right there. And so we can actually just look at these equations and determine that the number in front of the x is going to be our slope. And since slopes are the same in this case, 2/5 and 2/5, these are going to be parallel. And so we can answer this question parallel because the slopes are the same. And in this case, I'll go ahead and write it down too. It's going to be the slopes are both 2/5. Okay. We should also note that the y-intercepts here are different, which is a big part of that too. In the end, if the y-intercepts aren't different, of course, they're going to be the same line. But that's a very rare case. In this case, we're operating on the slopes, observing the slopes are good enough. And so for the first step, because the slopes are the same, they're going to be parallel. Let's slide up to this guy. All right, so in this case, they're given to us in a slope-intercept form, or sorry, a point-slope form. And so this y minus y1 equals m x minus x1. And so again, we can observe that we're looking just for the number that is in front of this x parentheses. And so in both these cases, we have one of those numbers. We have 4 and -4. So this one, the slope is just going to be 4. And this one, the slope is going to be -4. So when we're looking at parallel, perpendicular, and neither, well, if we look here, they're definitely not parallel because they're both not the same number. Even though they're 4s, one's positive, one's negative, which means it does fit the opposite part of opposite reciprocals. It fits this one, but it does not fit the first one. These are not opposite reciprocals, they're just opposites because the sign has changed. If these were opposite reciprocals, it would be like 4 and -1/4. And so these are going to be actually just neither. And then we can say that they are just opposites. They're not reciprocals. Okay? And so be careful on these because it's very tempting to say, well, look, they're really close. They're just one's negative the other. Therefore, they're perpendicular. That's not the case. They have to be complete opposites of each other, which means they have to flip the fractions and change the signs, which these do not do. Okay? This is probably the way that most of the problems are going to work are given to you, where they just have like two lines, L1 and L2, and they tell you the points they pass through. Well, this is easy. We're going to have to do two things here. The first thing we have to do is calculate slope. Okay, so for L1, remember the slope is going to be y2 minus y1 over x2 minus x1. In other words, change in y's over change in x. And so I'll call this point 1, I'll call this point 2. And so our slope calculation is going to be y2 minus y1 over x2 minus x1. And so in this case, it's going to be, you'll see, 11 minus 9, which are our y2 minus y1 value. And the bottom, keeping the same order, we'll have 1 subtract -2, x2 minus x1. So running out this calculation, we have 11 minus 9, which is 2. Remember, the two negatives will make a positive. So that'll be 1 plus 2, which is going to be 3. And so for L1, the slope is going to be 2/3. So switching this up to L2, again I'll label point 1 and point 2 here. So the calculation for L2 slope, we're going to use the same formula, y2 minus y1 over x2 minus x1. So pulling our values, y2 is going to be -9, subtract off a -6. And on the bottom for the x's, we'll have 6, subtract 4. Again, we have the two negatives here, which are going to make a positive. So 9 plus 6 is going to be a -3. On the bottom, 6 minus 4 is 2. So first we have to calculate slope. Now that we've calculated the slope, we can move on to part 2, which is now to compare slopes. Okay. So L1 has a slope of 2/3. L2 has a slope of -3/2. Okay, and so we have 2/3, we have -3/2. So these are going to be perpendicular. Okay. Now the reason these are going to be perpendicular is because they fit the mold of being opposite reciprocals. So again, if you remember opposite reciprocals, the fractions should have flipped and the signs should have changed. And so if we look at these side by side, the fractions certainly have flipped. Instead of 2/3, now we have 3/2, and the sign did change from positive to negative. And so those two things happened, so these have to be perpendicular slopes. So we're going to use as a template for this guy, or this last example here. Again, let's designate this guy point 1 and point 2 for the first guy, and point 1, point 2 for the second line. So for L1, so we have y2 minus y1 over x2 minus x1. Okay. So pulling values, that means we're going to have -4 for y2, subtract -8 for y1, -4 for x2, subtract -7 for x1. Continuing the calculation, again we have double negatives here, so that's actually going to be, let's see, -4 plus 8. That will leave us with a net +4. On the bottom we have -4 plus 7, and so that's going to leave us a net +3. So we have 4/3 for the slope of L1. Let's move on to L2. So the slope in this case, again, is going to be y2 minus y1, x2 minus x1. We've already designated our points. So our y2 value will be 5. Subtract off our y1 value, which is 1. On the bottom, we're going to have 5 minus 2. So the top will give us 5 minus 1, which is 4. 5 minus 2, which is 3. So we have 4/3. So if we have 4/3 for the first line, 4/3 for the second, this indeed will be parallel. This is because we have the same slopes. Okay. So not a crazy calculation compared to maybe the ones we've been doing in the past, but a calculation that needs to be mastered nevertheless. And so we have parallel, perpendicular. So just in summary, sometimes you have the equations to work from, in which case you just have to know how to get where to find those values in the equation. Sometimes you have to calculate the values, whether it be with a formal slope calculation, or thinking about the graph in terms of rise over run, which is the same as change in y over change in x. So sometimes you can just look at the graph and get those numbers. Otherwise, you're going to have to calculate using the slope formula. But in the end, we're trying to follow one of two rules. Parallel slopes mean they're completely identical because they change by the same amount. Perpendicular lines mean they're exactly opposite of one another. In this case, opposite reciprocals, meaning the fractions have flipped and the sign has changed. Like for example, we have 3/4 versus -4/3. It changes from positive to negative, and the fraction flips upside down for the perpendicular slope. So we see that in many different forms. Again, you can pull directly from the equation if you know how to look for it. Otherwise, you're going to have to calculate the slope separately and then follow the rules. Okay, that's all I can tell you about parallel and perpendicular slopes. Now it's about time to put it into action. So good luck.